Hello everyone. So today we are going to implement a system to share the environment query system results between enemy characters, so that when there is some major threat like an explosion, only one of the characters will go to the exact explosion location for searching, and other characters come around that location to search. So unlike previously, all of them will not try to go to the same location and do the searching. So they have some kind of a mutual understanding now, like one of us is searching that location, while he's doing that, let's search around the area. That's the kind of behavior we are going to implement today with sharing results of environment queries. So here is the demonstration. Let me make a noise by grenade. So one of them is coming to the grenade thrown location, and others came around that location. Now they are searching around to see if there is something. So they still haven't seen me. So if they don't see anything, they will just return to their normal duties after a while. So yeah, like that. So let's see how to implement this today. And this episode is sponsored by these generous patrons. Thank you very much for your support. So at the moment, if I throw a grenade to some place, these enemy characters, all of them will come to the same location to check that. So since that is so they just get flocked into the same location, which doesn't look very good. And we already implemented a system to make the AI characters react to these minor threats, minor noise like this rock throwing sound. So in that case, only one of the enemies are coming to check. So but for something like an explosion sound, it is not reasonable to come and search that location by only one enemy. So all of them should be alerted. So they should show that they should show that possibly there can be a fight. So they should show some different behavior there. So what I want to do is one character should come to the exact location of the explosion and check, while others search around or run around that location. So that's the way I want this to work. And also in this case, I want to share the EQS results, so environment query system results, so that no two characters will go to the same location for searching. So they should have some kind of a mutual agreement, like I am going there, you should go there, something like that. I want to replicate such a behavior. Right, so how can we do that? So for that, yeah, as I said, I am going to use environment queries, and also I am going to use this NPC manager that I added in a previous episode, that when we implement this, can I search for minor threat searching. Right, first thing we need is another environment query that gives us few locations around the major noise location, that means the explosion location. So if I open up some of the environment queries that I already have, let me open this flank location. Here we need to have EQS context provider. which says this is the location, that this is the location, or this is the actor that I need to generate the grid to apply these conditions and determine the best positions around that location. So yeah, so then for that, first thing is we need to be able to access the noise location and return it as a context for an environment query. Oh yes, so for that should be under artificial intelligence environment query. No, let's go here, EQS environment query context blueprint base. Let's use this, and I'll name this EQS context noise location. Right, now if I open this, here we can override to provide single location. So how can we access the noise location? For that, let's go to our AI controller, and this is the hearing perception component, and this is where we update the threat level and noise location. So I'll add a vector no, actually based on the threat level we can have different noise locations. So footstep sound should be stored as a minor threat location, minor noise location, and explosion sounds is a major threat location. So instead of making this a vector, let me add a int noise locations, and I'll convert this to a map. So the second parameter should be a vector. So we will be able to access, for example, if I add one element on the integer 0, we have this vector. On the if I make this 1, we can add another vector. So that's how basically maps work. So when I set the noise location here, I'll add an element to this map, noise locations map. So this index or this integer key should be this threat level that I have calculated based on this tag. So threat level should go here, and location is this. We already have that. I think it would be better if I put this part before this, before we set the noise location. The reason is, I think if I set this value even before we have noise location is stored in here, there could be a chance that behavior tree will try to access this. It's a very small chance, but I don't need to leave that. Okay, right, now we have saved the noise location in the noise locations map. The next thing is we need a way to access the noise location from the courier actor. So this is the AI controller. Let's go to CLM BPI AI controller and add get noise location. As an input, I'll give thread level. Should be an integer. And as an output, we need a vector. So what this says is, give me the location of the noise that comes under the given thread level. Now under the interface we have get noise location, we have the thread level. From this we can find the noise location from the given thread level. If we find one, we can return. Otherwise, if we find one, we can return that. Otherwise, even if we don't find one, maybe as the default value we will have 0 0, but I'm not sure. So let's add another return node like this and return 0 0. Or we can get that location. We can get control form and return that location. That would be better, I think. Right, now we do have a way to give the context. So the next thing I need is an environment query. Artificial intelligence environment query EQS get search locations, or shall we say get noise search locations. Okay, so under root we need to generate a grid. What kind of points we should generate? Well, shall we try a circle instead of a grid? Radius 1000, space between maybe not 50. No, let's try a grid, because I'm not sure if I draw a circle, will that consider... let's see, why not. Space between, let's keep it 200, number of points 8. Okay, environment context, circle center. As the center we should use EQS context noise location. And let's define a simple test, a distance test. From the distance also should be calculated from the noise location. filter type maximum value max, let's give 1200, and I'll make this -1. So we prefer closer points to the center of the circle. Right, now before making this a shared environment query, let's implement this on individual behavior trees to see how this works. So this should be implemented in search major thread. We should run EQS query before move to location and select EQS get noise search locations, and let's get the single best item, blackboard key, move to location. Right, now let's play and see how is the environment query is generated. Let me enable debug mode. So for environment queries, you can do that by pressing the apostrophe key in the keyboard and then using numpad 3. So you can use numpad 1, as you can see here, to enable and disable toggle AI debug lines. So 2 for behavior tree, 3 for EQS, and 4 for perception. Now let me throw a grenade. What's happening? Why only one of them is coming? This is the case. I forgot to implement this EQS context noise location. So we need to get AI controller and then run get noise location, and here we are interested in the interested threat level is major threat level, that means 2. Let's try again. Enable debugging of EQS. Right, now you can see the circle is generated like this, but they are only coming to the center. Okay, maybe rather than using a circle, I think it would be better to have a grid. So grid 500 space between 200. And we can use the same test and delete this. Context is noise location. Oh, right, now you can see the grid, but all of them are coming to the same location. That's a problem we have. So in order to solve this, we need to share the EQS query results and make sure that only one character is going to a single point. Also, I think it would be better to increase this gap, maybe 400, and also this 750. Yeah, that seems better, but still they are coming to the single point. Okay, so that's the easy part. So now instead of running this EQS query here, let me disconnect this. I am going to create a task to request the search location from the NPC manager, so that NPC manager will run the EQS query once and give locations for give different locations to search for each actor, each AI character who has heard that noise. I hope that's clear enough. So in order to do that, first thing is, let's create a function in the NPC manager. So get noise search location. So actually I will consider only the major noises are requested, but I won't get major noise, it becomes too long. So as an input we need to know the location where the noise occurred. So noise location, and also we may need, when we run EQS query, we need courier, which is an object reference. So I'll add that too. And so as I said, the whole idea of using this NPC manager to run EQS query is sharing the results. So if let's have another variable here, noise, previous noise location. Well, maybe preview part may not be necessary. This should be a vector. Let's keep it, no problem. So we have to check if these two are similar, at least not need to be exactly similar. Are these two closer? That's what we need to search. So if these two are in a range of 100 units, then I will consider it as the same noise location. So let's have a branch. If this condition true, that means we have already ran a query to find the locations around that given point. Now here we need to run that EQS get noise search locations, and here we can actually get query results as actors or location, but the problem is right after we call in this function, the results will not be ready. So we will basically get an empty array here. So therefore we have to use a callback here in order to actually get the results into a variable. So we can bind event to on query finished. and we don't have an event yet. So let's, under event dispatchers, let's create event. Let's create a matching event. I'll call it on query completed. When it is completed, we can get results, query results as locations, and I'll promote this to a variable. Let's call it search locations. So we need another variable to know that if we are still processing the results, we need another variable to tell that we are processing the results. So let's add another variable here, wait, boolean or EQS processing. By default it should be false. What's this? On query completed. Alright, maybe this is because this event is inside here. Okay, let me delete that. Let's create a matching function and paste. Right, now here I'll set processing to false, and here I'll set processing to true. Right, now still this is a function, and the idea of this function is to get noise search location. So if this is the first time that we are calling this function, we need to wait until the query is processed. So let's here add a return node. Return node should basically have wait input, so this should return true if we haven't processed the results yet. If this is the case, that means we have already requested to process the query, but still we don't know if it is finished or not. So in the false. Oh wait, wrong. So if these are same locations, we don't need to request again. If this is false, that means these are two different noise locations. In that case, we need to request to process a new environment query. If this is true, we have already processed that. So let's have a branch. Maybe return is not required here. Because we can use the same. If it is still processing, we should return with the wait true. If processing is false, that means we have already processed. So we should return one of the search locations. So let's get these, get length So we have to make sure that we have elements here. So if the length is larger than 0, that means we have elements in this array. Then we can return one of the elements, but we shouldn't return that twice. So what we can do is, from this we can get let's say a copy of the first element, and let's promote this to a local variable. Let's call it search location, and then let's remove that element from the array, then return. We should return the location, search location. Let's call it search location. Let's do it like this, it's more clear. Okay, and if we don't have elements, that means we have returned all the possible search locations. So let's add another return node, and let's return the location of the courier. Can we get location? Would this work? Let's change this to an actor instead of object. Courier, set to location. Okay, so that means don't go anywhere, just stay in your current location. Oh, this should return all machine results, not the single best or not any of these, all machine results. Right, now how do we get this from a behavior tree task? For that, this NPC character do have a reference to the NPC manager. So in the NPC character, let's through the CLM NPC, let's add another function, get noise search location. Let's put it under AI category. And as the outputs, we need a boolean and a vector. Boolean result is weight to match the return of this function, and search location. As an input, what do we need? We can give the major noise location. Or simply noise location. Right, now let's implement this in our ALS NPC character. The AI get noise search location. first we need to check if we have a valid NPC manager. Actually I do check that somewhere. Yeah, this is a very simple part, but still I want to reuse that. So let's collapse this to a macro. Get NPC manager. Right. Instead of this, let's use get NPC manager. If we do have a manager, we can call get noise search location. We can call that NPC manager function and return the result we get. If we don't, as the courier, we can give a reference to self. And if you don't have a valid NPC manager, we can return, no need to wait, we can return the same noise location. That means if we don't have an NPC manager, means the AI character should work independently. That means if there is a noise, he have to go there and search. It's not like he can wait for someone else to check that location. Right, that part is done. Now the only thing we need in order to call those things we implemented from the behavior tree is a task. So let's add a new task, bt task blueprint base. Let me rename this bt task get noise search location. Get noise search location. Okay, let's override receive execute AI, and from the controlled pawn we have two variables here. One is noise location, blackboard key, and this should be public. Another one is move to location. So we have to get the noise location and set the move to location. Move to location is also a blackboard key. So get the noise location, get value as vector, get blackboard value as vector. So this is the noise location, and from the pawn now we can call get noise get noise search location, that is implemented in CLM BPI NPC, and this is the major noise location. And if it says wait, if this wait is true, let's add a delay of 0.2 seconds and call the same function. The reason to do that is, so then when the next time when I call this function, that environment query I am processing here may have finished, and we will have the results in these search locations. If weight is false, that means we have the result here. So we can get the move to location, set value as vector, value is this value. Right, and then we need to finish this task. Finish, execute with success. Right, now we have the task. Only thing remaining is to call this get noise pt task get noise search location. We should do that before we call move to. Let me auto arrange. Now noise location should be set to noise location, move to location should be set to move to location, which is already set. Okay, let me save. I'm pretty sure I must have missed something, but let's test. Not correct. They are coming to the same location. Yeah, another problem we have here is I have forgot to set this preview noise location. Because of that, this condition always becomes false. Right, finally, I hope everything is correct now. Let's throw a grenade and test. Are they still coming to the same location? That looks like the case. To test that, where is the task? Here. Let's print a text. Now let's print this location. Oh wait, let's as vector. Let's get the blackboard value of the move to location as vector and print this in red or orange, so we can see if they are going to the same location. Actually no, see, these are different. These are different locations definitely, but they are still looks like flocking. These points are close. These points are close, so they are kind of taking the same path to reach that location. So we can increase the grid size. Let's make it 1000. Oh wait, that's not the case. The problem is here we are actually moving to noise location, not the move to location. So we have to change this to move to location. And here 750 should do fine, right? Oh, that's more like it. See, now one of them came to the middle and other people went around that, which is the exact behavior I need. And while they were searching around the location, one of them noticed me. Cool, let's try again. Great. Now they are searching around that location. Okay, none of them saw me through unit. Alright, so it's working as intended, and it took around 45 minutes. Okay, and thanks for watching. As always, project files will be available here in the Patreon page. For the download, link would be in the description below. And if you like to support my work, you can get the membership of the Patreon Club. See you in another episode. Goodbye.